Assalamualaikum warahmatullahi wabarakatuh. Hello, good evening everyone. Let me introduce myself. My name is Fatiyah Abubakar with student ID number 452423010 from the Geological Engineering Study Program, State University of Gorontalo. In this video, I will discuss material about geological map and interpretation. Lecture, Miss Dr. S.C. Yayu Indriati Arifin, MSc. Definition of geological maps. According to Moa Sally, in 2020, a geological maps, a map that provides an overview of the overall distribution and arrangement of rock bears urine, colored symmetric lines, and other signs. Meanwhile, according to Geology, in 2015, a geological maps 50, a map that prevent the unknown of rock types using color symbols, where our color indicates a certain type of rock can be said that a geological map is also a visual interpretation of the geological composition, structure, and geological history of a particular region or on the surface of the map. The second, what is an example of a geological map? The following is an example of a geological map. The geological map's function. 1. Identification of mineral deposits. Geological maps can help identify the location of mineral deposits in an area. It helps the mining company to determine whether an area is worthy of exploration or not. 2. Structured geology. Geological maps can also help in understanding the geological structure of an area, including the type of rock, the age of the rock, and the influence of tectonic events on the area. 3. Exploration planning. Using geological maps, mining companies can plan more efficient exploration programs. Geologic maps can help determine the location where potential rich mineral deposits are most likely to be located. 4. Mine planning. Geological maps can also help in mine planning, including mining design, selection of suitable mining techniques, and determination of optimal mining areas. It helps mining companies to reduce cost and improve mining efficiency. Type of geological maps: surface geological maps, structural maps, mineral zoning maps, hydrogeological maps, seismic maps, volcanology map, sedimentary geology maps, subsurface geological map, geological geomorphological map, stratigraphic map, lithology map, flow direction map, mineral resource map. Geological symbols indicate geological information such as rock type, usually with a symbol or color, rock deformation, faults, symbols and lines, and rock age with abbreviated geological time scale information. A geological map is a technical description that describes the condition of an area, which includes the composition of the rock found in the area, as well as the structural form of each rock unit. Geological maps are also information that includes rock types, rock thickness and direction, rock unit arrangement, layer structure, faults, joints, and folding and process that occur in the area. First, creation of complex layered geological maps. Second, steps for making a geological map of inclined layers, horizontal layer geological map. Summary of environmental geology material from meeting 7 interpretation of geological and geomorphological maps. Interpretation of geological geomorphological maps is the process of interpreting and drawing geological or geomorphological maps. Making geological and geomorphological map is based on topographic maps, which generally have scales of 1 in 20,000, 1 in 25,000, 1,000, 1 in 50,000, 1 in 100,000, 1 in 250,000, 1 in 500,000, and 1 in 1 million. Interpretation of geological and morphological maps regarding rocks can be observed on a topographic map. Basic understanding of structural geology is the part of geology that studies the shape of rocks as a result of deformation process. The deformation process is a change in the shape and size of rocks as a result of force that occur within the earth. This force is basically a tectonic process that occurs within the earth. The movement of plates can be in the form of movements approaching each other convergent, moving away from each other divergent, and passing each other transform. There are three types of geological structure. First, features. 2, fault, and 3, faults. Fractures. Joints are fracture structures. Fractures are formed in a rock due to a force acting on the rock and have not yet shifted. Weakness is usual caused by the stone's inability to withstand too much pressure. As a result, rocks experience cracks at their weakest points. Joint structures are one of the easiest geological structures to find in almost all rocks exposed on the surface. The formation of this joint structure can be occur simultaneously with the formation of the rock or after the rock is litiated and can occur at any time. Although this joint structure is the easiest to find, it is the most difficult part to analyze. The main difficulties in analyzing this rigid structure include can be formed at any time due to tectonic or non-tectonic impacts. It is difficult to determine the relative displacement of joint planes. It is difficult to determine the sequence of formation of intersecting joints. It is difficult to determine the types of joints in the field. Fault is a crack that has movement in the direction of the crack. The size of the movement is relative and its importance is also relative. Fault dimensions can reach hundreds of kilometers in length. Some faults are only change a few centimeters. The direction of fault movement is called the fault plane. The fault plane is a plane that represents the fracture surface of the fault. A fault track or fault line is the intersection of a fault plane with the ground surface. A fault trace is usually plotted on a geological map to represent a fault. The fault plane includes the hanging wall and footwall. The characteristics of a thrust fault are such that a fault is called a thrust fault. Thrust error. Slopes up steep, symptom of general inhibition. Complex fault line, normal error or lower error, steep slope, penetrate the layer of underground sediment, from a branch like thrust and strike a mistake, strike slip mistake, horizontal fault strike, easy to spot from a distance, the bird is a major error and is sensitive to erosion. Faults. Faults are deformations of rock layers that occur as a result of compression force so that the rock moves from its original position to form an edge. Based on the shape of the curve, the faults are divided into two, namely the syncline fault, which is a fault that is concave towards the top. Meanwhile, the ankyline fault is a fault that is convex towards the top. Based on the slope of the wings of a fault, faults can be divided into several types, namely, first, symmetrical faults are faults where the slope of the rock layers on both wings has the same angle. Second, asymmetric faults are faults where the slope of the rock layers on both wings is is not the same. Third, an overturned fault is a fault in which bat wings experience a reversal in the direction of the slope of the rock layers. Types of faults: angular unconformity. Faults formed due to an angle between the outer and younger layers. Disconformity: there are missing layers between the outer layer and the younger layer, so the age of the two layers have a very large difference. Nonconformity: the existence of crystalline, igneous, or metamorphic rocks which are directly related to sedimentary rocks. Conclusion: based on the explanation and brief description above, it can be concluded that the geological map is basically a means of describing rock bodies, distribution rocks, the position of geological structural elements, and the relationships between rock units, and summarize various other data. Geological maps are also technical depiction of the Earth's surface and part of the subsurface that has direction. Its elements are an image. Geology expresses a line that has a definite position. Basically, a map. Geology is a series of results from various field studies.